Hello class, and welcome to the second lesson in Chapter 8 on hypothesis testing. So today we're going to discuss the z-test process. So the z-test is a specific hypothesis test that you use when you want to test a claim about the mean, assuming that you have a large enough sample. So we want to, the couple questions that we want to discuss are, what is the z-test, when do we use it, and what is the procedure for the z-test. So regardless of which type of test you're using, you want to be able to calculate what we call a test statistic or a test value. So in order to calculate a test value, you take your observed value minus your expected value over your standard error. So your expected value is generally, your hypothesis value. The observed value is the actual characteristic that you observe, so this is usually from the sample. So this is the sample statistic. So it's usually the sample statistic minus the parameter divided by the standard error. And the standard error in the example of the mean is sigma over square root of n, which I have labeled already for convenience. Alright, so the z-test is a statistical test that for the mean of a population. So if you want to find the mean of a particular population, assuming that the sample size is greater than or equal to 30. So if the sample is large enough, then you can go ahead and proceed with the z-test. So the formula for the z-test is the same formula that we use for the central limit theorem and those other lessons. So assumptions for the z-test. You have to assume that the sample taken is taken completely randomly, just like with any kind of test. And the sample size has to be greater than or equal to 30, or the population standard deviation is known, and the population is normally distributed. Okay, so a couple things can take place, right? So you can either have a sample size greater than or equal to 30, or if it is less than 30, you have to know the population standard deviation, and the symbol for that is sigma, and the population has to be normally distributed. So you have to have those two characteristics, standard deviation known and normal distributed, if you don't have sample size greater than 30. Alright, so what is the process for hypothesis testing? It's just like it was when we discussed it in lesson 1, and it is these 5 steps. So you're going to state the hypotheses, identify your critical value, compute your test value, also known as a test statistic. You're going to either decide to reject or fail to reject the null hypothesis, that's H sub 0, and then summarize and draw a conclusion. Alright, so let's take a look at the process. So in Pennsylvania, the average IQ score is 101.5. The variable is normally distributed, and the population standard deviation is 15. The school superintendent claims that the students in her school district have an IQ higher than the average of 101.5. She selects a random sample of 30 students and finds that the mean of the test scores is 106.4. Test the claim at alpha equals 0.05. So looks like here they specifically mentioned that the claim is that the students have an IQ that is higher than 101.5. So let's go ahead and set up the first statement here. So we have H0 and HA or H1. So it looks like they said that the claim is that it is greater than 105. So greater than, so this is the greater than symbol, is a statement of inequality. So that belongs to the alternative. So we have the mu is greater than 101.5. And this so happens to be the claim here. This is what they said is the claim. Okay, so at this point you can say that the null hypothesis is the opposite of this statement, or the complement. So you can say less than or equal to, or you can use the fact that it says here that the average IQ score is 101.5. So you can also use this as your null hypothesis. Okay, so we have equals to 101.5, or you can simply say greater than or equal to 101.5, just so that you can oppose the alternative. In this case, I'm going to leave it as equal to. Alright, so that means that this is a right-tailed test because the alternative hypothesis is pointing to the right. It's a greater than symbol. Alright, so now step 2, we want to find the critical value. So as I mentioned earlier, this is a right-tailed test. Therefore, we want to be able to find the critical value on the right side, on the right tail. So I'm going to do that real quick here. So I'm just going to quickly draw a curve. So this is a standard normal distribution with a standard deviation of 0 and a standard deviation of 1 and a mean of 0. And we are labeling the right side. So since this is a right-tailed test, we want to look for 1 minus alpha instead of alpha, okay? If it's a left-tailed test, we would use alpha. But since we're looking at the right side, we want 1 minus alpha. So that means that an alpha was 0.05, so we have 1 minus 0.05. Let me go ahead and erase this real quick. Is 0.95. So we're going to look up this value in the z-chart. So we're going to look this guy up. Since we are using the z-test, we are going to be using the standard normal distribution chart. Alright, so in this example, this is the standard normal distribution chart that we're using. And we're going to look up an area of 0.95. So in this example, if you look here, 0.95 is sort of between those two values there. So let me highlight those two values. So I'm going to just choose the first one. So I have 1.64. So 1.64 is my z-score. Alright, so we have 1.64 over here, and that's my z-critical. And so we're going to shade that right area. This right here is my alpha, which is my rejection region. So that's step 2, find the critical value. Step 3 is to find the test value. So we need to calculate z-test. So we're going to use the formula for x bar for z-test. This is the formula right here for z-test. So x bar minus mu over sigma over square root of n. So in this example, if you look here, the x bar is 106.4. The mu is the hypothesis value, which is 101.5. The sample size is 30 students, which is greater than 30 or equal to 30, which is why we're using the z-test. And finally, the standard deviation, they said, is 15. So we're going to go ahead and plug in those values. So we have 106.4 minus 101.5 divided by 15 over square root of 30. We plug that into the calculator, we get a z-score of 1.79. So what we're going to do is we're going to label the z-score on the graph here. So if I label it, and I'm going to label it in a different color here, right here, so this is 1.79, then we can tell that it is strictly in the rejection region, which means we reject the null hypothesis. Alright, so since it is in the rejection region, so step 4 is to make a decision. So this is in the rejection region. As we can tell, it's in the shaded region here. So it's in the rejection region, so that means we reject the null hypothesis. So step 5 is to make a summary. So we're going to summarize our results, alright? So since our claim belongs to our alternative hypothesis, this means that we're going to use the word support, and since we rejected, we're going to use the phrase "there is enough evidence." Okay, so since we're rejecting, we're going to say there is enough evidence at the, in this case, we're looking at alpha is 0.05, so at the 5% level of significance, LOS, to, so instead of using the word support, we're going to use the word, or I'm sorry, instead of using the word reject, we're going to say support, because the claim belongs to the alternative hypothesis. To support the claim that, and then use the claim that they give you. The claim was that the students have an IQ score, have an IQ higher than 101.5. So students have IQ greater than 101.5. All right, so let's look at another example. This particular problem has a bunch of numbers that we're gonna be using to actually make the calculation. So with number one, they didn't give us any data to make any calculations, and number two, they're actually giving us the data, and we have to use it in order to find the average. Okay, so for a specific year, the average score on the SAT was 515. The variable is normally distributed, and the population standard deviation is 100. Okay, so we have that the average score, so that's the population average, is 515. The population standard deviation is 100. I'm sorry, 100. The variable is normally distributed. The same superintendent in the previous example wishes to see if her students scored significantly below the national average on the test. She randomly selected 36 student scores, so my N is 36 here. At alpha equals 0.10, is there enough evidence to support the claim? So here they're saying support the claim. The claim is referring to the fact that, you know, the students scored significantly below the national average, okay? And the reason I know that's the claim is because that's what this is referring to. This is the sentence that that's referring to. It's saying, is there enough evidence to support the statement that the students scored below the national average? So in this case, they're implying that that's the claim. So in this case, they said significantly below, so that's the inequality symbol, less than. Okay, so in this example, we're going to be looking at the first step is the hypothesis statements. So since it's less than, this is a statement of inequality, we're going to assign that to the alternative hypothesis. So it says below the national average of 515. Okay, and you can use greater than or equal to 15, or you can say that it's equal to 515 because that's what this statement says here in the first sentence. So we'll just use that. Looking at this, this is a left-tailed test because the alternative hypothesis is pointing to the left, the inequality symbol. All right, so we have all the variables except for x bar. So we need to use the data here in order to calculate x bar. So if you plug that into the calculator, add them all up, and then divide by 36, or use data calculation methods in the calculator, you will get a average of 509.028. All right, so now that we got the x bar using the calculator, we're going to go ahead and proceed with the next step. And we're going to go ahead and label this. This is my claim. That way we can use that later whenever we do the conclusion. So step 2, we want to find the critical value. So that means that we are, in this case, we are doing a left-tailed test because this is pointing to the left, the alternative hypothesis. So left-tailed test. Because we're doing a left-tailed test, that means we're simply going to use alpha. We're not going to use 1 minus alpha. So in this case, alpha is 0.10. Again, if it were a right-tailed test, we would use 1 minus alpha. If it were a two-tailed test, we would divide this alpha by 2. So in this example, we have a bell curve as shown. Now, since we're doing a left-tailed test, that means that I need to find a critical value on the left side, and the z-test or the z-chart gives you the area on the left side by default, which is why we're using 0.10 as our area. So if we go back to the z-chart, see, it says here that the table values represent area to the left. So therefore, we're just looking for 0.10. So we need to go to the area of 0.10. In this example, it looks like this is 0.09. We got to get closer to 0.10. This is 0.109, 0.100. So we're getting closer there. That's actually pretty close to the value. So I think that's the closest that we're going to get to 0.10. So therefore, we're going to use that value. So negative 1.28 is our z critical value. Okay, so negative 1.28 is around here. So z critical, about negative 1.28. Okay, so this right here, since this is our critical value, this means that this right here, the left-tailed region here, is my rejection region. All right, so now we need to calculate the test value to see if it's in the rejection region or not. So that's where the z-test comes in. So we're going to use the formula x bar minus mu, so it's 509.028 minus mu, which is 515, over sigma. Sigma in the problem is 100 divided by square root of 36. Divided by square root of n, which is 36. If you were to plug in into the calculator, you're going to get a z-score of negative 0.36. All right, which that value, we'll do that in another color, is around here. So that's negative 0.36. So this is clearly outside of the rejection region. So this means that we fail to reject. So we fail to reject the null hypothesis. That's our decision. So step 5, since we fail to reject, we're going to use the phrase, there is not enough evidence. Since our claim belongs to our alternative hypothesis, we're going to use the word support instead of reject. So there is not enough evidence, or there is insufficient evidence. So there is not enough evidence at the 10% level of significance, LOS, to support the claim that, and the claim was that the students scored below the national average. So that students scored significantly below national average. So we don't have enough evidence to show that they scored below everyone else on average, the population. Okay? All right. So we're going to go ahead and do another example here. So the Medical Rehabilitation Education Foundation reports that the average cost of rehabilitation for stroke victims is $24,672. To see if the average cost of rehabilitation is different at a particular hospital, a researcher selects a random sample of 35 stroke victims at the hospital and finds that the average cost of their rehabilitation is $26,342. The standard deviation of the population is $3,251 at alpha equals 0.01. Can it be concluded that the average cost of stroke rehabilitation at a particular hospital is different from $24,672? So in this case, so here it looks like they're saying it reports. So if they report that that's the average cost, we're going to take that as our claim. So they claim that the average cost is $24,672. So I will call that my claim. So for step 1, we have H0, HA. So this claim is that it's equal to 24,672. An equal sign means that that belongs to the null hypothesis. Okay, so if it has any sort of equality, it belongs to the null. So mu equals $24,672, and that happens to be our claim. All right, so we want to see that the average cost is different from that value, which means does not equal to. All right, so that means that if it's not equal to, that means this is a two-tailed test. Let's go ahead and label all our variables. So we have mu is $24,672. X bar is $26,343. And this is because they took a sample of 35 stroke victims and found that that was their cost on average. The sample size is 35, which is greater than or equal to 30. So that means we are going to use a z-test, so that checks out. We have our alpha, and the last thing is the standard deviation. So the standard deviation here is 3,251. All right, so we can go ahead and plug in the numbers, but before we do that, we need to do our step 2, which is the critical value. So this is a two-tailed test because the alternative hypothesis doesn't have any direction. So it has both directions, basically, is what I'm trying to say, because it doesn't have a less than or greater than symbol. So this is a two-tailed test, which means we need to take the alpha and divide it by 2. So we're gonna need alpha divided by 2 here. So alpha is 10% right here, or is 1%. So we got the 1% level of significance here. So we have 0.01 divided by 2, 0.005. So we're going to use this to look up what our critical values are. So notice that there should be 2 critical values here, right? So I'm going to go ahead and label them on here. So we got 0, 1, 2, 3, -1, -2, -3. All right, so if we look up 0.05 on our Z chart, so 0.005, 005. This should be 0.005. All right, so this looks pretty close, and this looks pretty close. So this looks like the closest that we'll get. So that's a value of 2.58. So that's the value that we're going to be using. So 2.58, and it was negative. So that means we got a z-crit of negative 2.58. So that's over here. All right, but since it's a two-tailed test, we have a positive version over here. All right, so because we have both versions, so we have 2 z criticals. So both sides are shaded, so we have 2 rejection regions here. So we have a rejection region here, RR, we'll just call that RR for rejection region, and a rejection region there. Okay, so whichever side we happen to be on, if it's in any of those rejection regions, we reject the null hypothesis. All right, so we're going to calculate our test value. So x bar minus mu, so our x bar in this example is 26,343 minus mu divided by standard deviation is 3251 over square root of the sample size. We're doing it for 35 stroke victims. So you plug this in the calculator, you get a z-score of 3.04. So that means that that value is all the way over here. So that value is 3.04, which means that we're in our rejection region. So that means we will reject. So let me just write step 4 over here. Step 4, we reject our null hypothesis. So then step 5, since we reject it, we're going to say we have sufficient evidence, or we have enough evidence. Since our claim belongs to our null hypothesis this time, we're going to use the word reject. Okay? So there is enough evidence at the 1% level of significance to reject, instead of support, the claim that the average cost of stroke rehabilitation, stroke rehab, is $24,672. All right, so now this is what is known as the traditional method. So there's another method to be able to hypothesis test, and that is the p-value method. So what is a p-value? So a p-value is also known as probability value. And this is the probability of getting a sample statistic. Statistic is what you calculate. So this is the probability of getting a sample statistic. Let me go ahead and get rid of this real quick. A sample statistic, such as x bar. So x bar is a sample statistic. It's something that you measure and you calculate based on your data, on your sample. So the probability of getting that sample statistic value, or a more extreme value, in the direction of the alternative hypothesis. Okay? So the alternative. Assuming that the null hypothesis is true. So for example, if I get a value of, if I get an x bar of 5 and I'm doing a right-tailed test, then the p-value is simply the probability of getting a value at 5 for my x bar, or greater than, which is more extreme. If I'm doing a left-tailed and I get an x bar of, say, -2, then, or that doesn't really make sense in this context, but let's use an x bar of, say, 1 or something. So let's say I get an x bar of, say, 1, then what is the probability that I get a value of 1 or less, more extreme? And that's for a left-tailed test. If I'm doing a two-tailed test, then really I'm looking at both directions. So this is for a left-tailed. If I were to do a two-tailed test, so let's say I got x bar equals so x bar equals 2 or something, then it's the probability of getting a sample statistic of either 2 in the positive direction or -2 in the other direction. So it's basically a probability of getting either side of the spectrum. Okay. In this case, the x bar that we usually plug in here is not x bar. We usually use z, because z is what we're interested in. But the idea remains the same nonetheless. So right-tailed test, you're looking at the p-value to the right. Left-tailed test, you're looking at the p-value to the left. Two-tailed test, you're looking at both areas combined to give you the p-value. So the decision process for the p-value. Once you find the p-value, you compare it to your level of significance. So if the p-value is less than or equal to the level of significance, then you reject the null hypothesis. So I should probably name this. So you reject the null hypothesis. If the p-value is greater than alpha, then you fail to reject the null hypothesis. Alright, so here's the outline of the procedure. So first step is state the hypotheses and identify the claim, just like it was for before. However, the second step this time, instead of finding the critical value, you're not concerned with the critical value as much as you are concerned with the p-value in step 3. So in step 2, you calculate your z-test, then you find your p-value, and then you decide. Okay, so let's go ahead and show you how this works. So a researcher wishes to test the claim that the average cost of tuition and fees at a 4-year public college is greater than $5,700. So that's her claim. She selects a random sample of 36 4-year public colleges and finds the mean to be $5,950. The population standard deviation is $659. Is there enough evidence to support the claim at this alpha level significance of 5%? Use the p-value method. So let's go ahead and list our variables first of all. So we know that the mean is based off of the claim. So the claim is that it's greater than, so this is the greater than symbol. So basically we're testing, $5,700. So that's like our basic hypothesis that we're testing. So mu equals $5,700 in our calculations, right? Even though the claim says it's greater than, we're going to be testing at $5,700. The x bar is our sample average. So it says here she selects a sample of 36 4-year public colleges, finds the mean to be $5,950. So that's our x bar is our sample mean, sample average. The n is how many colleges, so 36. Standard deviation is $659. All right, so let's write out our hypothesis statement. So H0 and HA. Okay, so the claim is that it's greater than 5,700. So if it's greater than, that means it's an inequality, right? So that means it's going to belong to the alternative. Remember that the alternative is a statement of inequality. The null hypothesis is a statement of equality. So we have here mu is greater than $5,700. Okay? At this point, we can either say that the null hypothesis is equal to 5,700, or we can say that it's less than or equal to 5,700, which is what I'm going to go with. All right? So sometimes you'll see it written as mu equals, but technically speaking, if you want to go directly opposite or the complement, you want to use less than or equal to, especially since it has no mention of saying that it is exactly equal to 5,700. All right? So we're just going to use less than or equal to here. But keep in mind that our claim belongs to our alternative here. All right, so the second step, we want to calculate the z-test. So we're going straight for it. So we're going to put in our numbers. So x bar minus mu divided by sigma over square root of n. You're going to get 2.28 for the z-test. So what we're going to do is we're going to label that z-test. Now we know that we're dealing with a right-tailed test. So for the third step, we know that we're dealing with a right-tailed because the alternative hypothesis is greater than, which is an arrow pointing to the right. So right-tailed test. So if we label it on our chart, we have 0, 1, 2, 3. So we have 2.28 over here. So that's our z-test. And we don't have a negative version on the other side because we're only doing a one-tailed test. So we're going to shade the right side. So this right here is my p-value because we're doing a right-tailed test and we're looking at the area to the right of the test value. So the area for the test value is the p-value. So notice that this is not the rejection region. This is the p-value. The rejection region is labeled whenever we find the critical value. We have not found the critical value here, so we're simply looking at the p-value. So we need to find this p-value, so we're going to look it up on the z-chart. But remember that the z-chart gives us the area to the left, okay? So we're going to do 1 minus the area on the z-chart. Then we're going to look up 2.28. So let's look up 2.28 on the z-chart. So we got to go to the positives here. So we're looking up for a z-score of 2.28. 2.28. 0, 1. So this is 2.28 over here. So that's the area of 0.9887. But we gotta, so that's what that area is, but we gotta do 1 minus. And let me double check that value. So 9887. Okay, remember that we gotta do the left, we gotta do 1 minus because the chart gives us the area to the left, right, by default. So we don't want the area to the left, we want the area to the right. But we do know that the left and the right side add up to 1. So therefore, we do 1 minus. All right, so we got 0.0113, if I did that math correctly. So that's my p-value. So p-value 0.0113. All right, so now that we got our p-value, we can go ahead and compare that to my alpha, all right? So the p-value, which is 0.0113, is greater than or less than alpha. Well, the alpha is 0.05. So this is technically less than or equal to alpha, and alpha is 0.05. So this is less than 0.05, which means that we reject the null hypothesis. That's all you got to do. You don't even have to label anything on here except for the p-value and the z-test. You just have to compare it to alpha. So therefore we reject. Since we reject, we use the phrase there is sufficient evidence or there is enough evidence. Since the claim belongs to the H0, or the HA, I'm sorry, that means we're going to be using the word support. So there is enough evidence at the 5% level of significance to support claim so the claim was that the average tuition is greater than $5,700. That average tuition of 4-year, so it says it's a 4-year public school, public college. Is greater than $5,700. All right, and that concludes that problem. So last problem, we're going to be looking at another type of test, a two-tailed test from the looks of it. So it says the researcher claims that the average wind speed in a city is 8 miles per hour. So that's our claim, underline that. So let's go ahead and label that as our first step. So we have our null and alternative hypotheses. So since it says it is, that means we're going to use the symbol equal to. An equality statement belongs to the null hypothesis, so that means the mu is equal to 8. And that's our claim here. It's saying, is there enough evidence? So it says the standard deviation is 0.6. Is there enough evidence to reject the claim? So it doesn't tell us any direction whatsoever. So it doesn't say whether it's greater than or less than. So we're going to assume that it's on both sides. So we're going to say it does not equal to 8. All right, and that's our alternative. We're going to go ahead and label all the variables here. So we have mu is 8, x bar is 8.2. They found that from the wind speed, the average wind speed for 32 days. So 32 days, that's n, which is greater than 30. Which means that we can use a z-test, which we knew that already, it's a textbook problem. Standard deviation is 0.6, and we have our alpha. So second step is calculate your z-test. So we have 8.2 x bar minus mu divided by sigma over square root of n. When we calculate that, we get 2.28. As our test value. So we're going to go ahead and label this on our test value. Remember that third step is find the p-value. So I'm just going to quickly label this. So we have 2.28 around here. And since it is a two-tailed test, that means that we have a positive and a negative version. So that means that I'm going to do a negative version here because it's two-tailed, and then I'm going to shade both tails. All right. Now this simply means that the alpha is split between both tails, or in this case, I'm sorry, the p-value is split between both tails. So both of these represent our p-values. Okay. So this is a p-value. So the p-value is a combination of both of these. Okay. So what we need to do is we need to combine. We need to figure out what this area is, and then double it because this area is the same as that area. Okay. So if we find one, we know the other. So we're going to look up we're going to look up on the table a z-score of negative 2.28 to figure out what the area is. So let's go to the negative z-scores here. Negative 2.28 is that as our area, so 0.0113. So this right here is 0.0113, I believe. Let me double check that. Okay, which means that this is also 0.0113, so we can double it to get our p-value. So this is 0.0226 as our p-value. All right. Step 3 is done. Step 4, we're going to compare the p-value to our alpha. So our alpha here is 0.05. So that is less than or equal to alpha, which is 0.05, which means that we reject. So therefore, we reject the null hypothesis. So we're going to use the phrase, there is sufficient evidence. Now, since our claim belongs to our null hypothesis, or H0, we're going to use the word reject. So there is enough evidence at the 5% level of significance to reject the claim that the average wind speed is 8 miles per hour. All right, so those are the two methods. So we did the traditional method, which is finding the critical values and in our rejection regions. And then the p-value method, you're not really finding your rejection region, you're just finding the p-value, comparing it to your alpha. Okay, so on one hand, you're finding your critical regions, which is your rejection region, which is critical values. And on the other hand, you're finding the p-value to compare it to your alpha. All right, in either case, whichever method you employ, you're still going to reach the same conclusion. So therefore, your summary should be the exact same as it would be for the other method. All right, guys, that's it. I hope you learned something from this and took something from this. I will see you guys next time.